Hello students, my name is Ashish Pradhan and in this lecture you will be able to understand the FCFS CPU scheduling algorithm. Before we go into the depth of the topic, let me inform you that if you want to execute any program, that program has to be brought from secondary storage device into a main memory, and then from the main memory CPU can execute the instruction directly. So in CPU scheduling algorithm, the program that you want to execute that has to be brought into the main memory and has to be kept into the ready queue. Then CPU is assigned to that respective process. So we'll learn more about the FCFS CPU scheduling algorithm. So it is the first CPU scheduling algorithm that we are going to discuss and we are going to implement it. FCFS stands for first come first serve. So whichever process comes or arrives at the system first, that respective process will be given the first preference to execute it. Now next is the principle. The principle I have already told you that the process who came at the ready queue or the main memory in which in order in increasing order or as per the arrival time, then that process will be first preference to utilize or use the resource that is CPU to execute their instruction. CPU is the FCFS is a non-preemptive CPU scheduling algorithm. However, it can also be implemented for preemptive case, but it is commonly used or it is an exclusive non-preemptive CPU scheduling algorithm. So now what do we mean by non-preemptive CPU scheduling algorithm? So non-preemptive CPU scheduling algorithm means once you assign a resource to a process, the process will release the resource voluntarily after completing all the instruction executions. So, so non-preemptive means the execution of a process cannot be interrupted in between. So that is the meaning of non-preemptive CPU scheduling algorithm. So now we'll try to understand or we'll try to get ourselves familiarized with some of the technical terms associated with CPU scheduling algorithms. So we'll try to introduce uh, waiting time and turnaround time. Let us try to understand waiting time with the help of pictorial diagrams or representations. So say for example, a process has arrived from the secondary storage device to a ready queue or a RAM or a main memory at time ti. So at this time ti, a process have arrived at the system or at the ready queue or at the main memory. Now, as and when the particular process have arrived in the RAM or a main memory, it might happen that CPU is busy executing the instruction of another process. So basically, the current process has to wait. So now, say for example, there is another time T naught. Okay, so T naught is a time that current process is has started execution waiting after completing its waiting time. So meaning is that at time t naught the CPU was free, or CPU became free. Now it can give a chance to a currently arrived process for execution its instruction. So let us consider t naught is a time that CPU starts its execution for a currently arrived process. So we can consider that T naught as a start time of the currently executing process. So now we'll try to introduce waiting time. So basically the waiting time formula would be the start time, that is T naught, minus the arrival time of the process into the system or the ready queue. So that is the formula for waiting time. Now let us now we found that from Ti to T naught process currently the current process from Ti to T naught, the current process has waited. Now and then from T naught onwards, the execution of current process started. So now next is the completion time. So say for example, the TP is the completion time for the current process for completely executing its instruction. So the current process has started its execution from T naught and has completed execution at TP. So basically, the end time of the process or the completion time of the process is TP. So we can also say that the amount of time elapsed between T naught to TP is known as execution time or the burst time. So commonly used terms are burst time and execution time. right? So now start time equals to execution end of execution and time of previous process. So there may be list of process. Okay, so there may be list of process executing one after another. So what will be the start time of each and every process? For the first time, the start time would be 0 if the execution starts from 0, and from the subsequent for the subsequent process, start time would be waiting time or the burst time of end time of previous process. So we'll understand in more detail about the start time and end time uh, in the with the help of examples in upcoming examples. Now let us try to understand the turnaround time. So turnaround time means that when the job was completed and and when it has came out of the system. So for the current process, we found that Ti was the time that the current process came into the system, and TP is the time that the current process went out of the system. So turnaround time would be the formula for turnaround time would be waiting time plus execution time or burst time. So the time period between job submission to job completion is the definition for turnaround time. So these are the few technical terms that I would like to introduce so that for upcoming slides it would be easy for us to understand. So whenever we deal with any of the CPU scheduling algorithm, our requirement is the our requirement would be minimization of waiting time. So that CPU scheduling algorithm is best from the list of CPU scheduling algorithm whose average waiting time is minimum. So average waiting time is minimum indicates that the processes or the list of process has to wait for minimal amount of time. So which algorithm leaves you or provides you or gives you uh, with minimum average waiting time. So that respective algorithm is best for the system or for the operating system. So that is our search. So let us now try to understand the FCFS with the help of numerical example. Let us consider there are four processes J1, J2, J3 and J4 with the burst time or the execution time of 15, 8, 10, 3 units or milliseconds. So these jobs J1, J2, J3 and J4 have came into the system or into ready queue in this order from J1 to J2, J2 to J3, J3 to J4. So if you want to schedule all, say for example, let us assume that all of them have arrived into the system at time t equals to 0 in this order J1, J2, J3 and J4. Time arrival time of all this process is 0 for this example. This is my assumptions. Okay, arrival time is 0. So order of arrival is J1, J2, J3 and J4. So if now we need to first schedule this process for execution. So if we draw the Gantt chart. So since J1 have in the is say since J1 is in the first in the ordered list, so J1 will get the first chance to execute it. And again, I have told you already that FCFS is a non-preemptive, is an exclusive non-preemptive CPU sharing algorithm. So J1 execution will not be interrupted in between. So J1, the execution time is 15. So only after completely executing all the instruction as written inside the J1 job will get completely executed, then only CPU will get released voluntarily by the job J1. So J1 will complete its execution at time frame 0 to 15. Then after that, J2 will start its execution. Okay, so J2 has started its execution after 15 units of time. Okay, so basically J2 has waited for 15 and then on the J2 execution has started. J1 completion time is 15 and J2 start time is 15. Then after that, J3 has begin its execution at time 15 plus 8, so that is 23. Likewise, J4 has started its execution at time 15 plus 8 plus 10. So 15 plus 8 plus 10 is the amount of time that J4 has waited to begin its execution. So now let us try to have a complete scenario about when J1 has completed, J2 has completed execution and so on. So J1 has completed the execution 15 units of time. J2 has completed execution at 15 plus 8 units of time. So now we'll try to understand the completion time of each and every process. J1 has completed its execution at time 15. J2 has completed its execution at time 15 plus 8, that is 23. And J3 has completed its execution at time 15 plus 8 plus 10. So 25 plus 8 is 33. And J4 has completed its task at time 36. So these are the start time and end time of each and every individual. So let us try to calculate the waiting time. Okay, so waiting time for J1 is 0, because as and when J1 have arrived, I'm assuming that CPU was free. Although practically speaking, it is CPU is generally not free, but ideally I'm speaking that J1, say for example, CPU is currently idle. J1, J2, J3, J4 came into the ready queue in this order, and at time t equals to 0, so J1 immediately got a chance to execute its instruction. That's why J1 waiting time is 0. Now J2. J2 has waiting time of 15 units of time, because J2 cannot start its execution immediately, because J1 priority is higher, because it has arrived into the ready queue first. Likewise, J3 and J4, the waiting time is 23 and 33. So how do we get it? So the waiting time formula is we have seen this. Okay, waiting time formula is start time minus arrival time. So from this Gantt chart, we can easily identify the start time and arrival time for all the processes 0. So J2 start time is 15. J2 start time is 15. 15 minus 0 is 15. And J3 start time is 23. J3 start time is 23. So 23 minus 0 is 23. So likewise, we'll get J4 as well. So now we need to calculate the average waiting time. So if you sum it up, all this waiting time for each and every individual process or job. So 0 plus 15 plus 23 plus 33, the summation is 71, divided by 4 is the average. So you'll get it as a 17.75 units. So if the unit is given in millisecond, then you need to specify units as milliseconds. Instead of units, you need to specify milliseconds. So now we'll consider the another example with the arrival time. The previous example was without the arrival time. So this is an process details. The content is same. The burst time is same. I just simply rename the job by P, J by P. So there are 4 processes into the system that came into the ready queue. So there, I repeat, there are 4 processes that came into the ready queue, and the name of those processes are P1, P2, P3, and P4. P1, P2, P3, and P4. The arrival time for P1 is 0, the arrival time for P2 is 1, the arrival time for P3 is 2, and the arrival time for P4 is 3. So considering the arrival time, how to calculate it? So our in any case, our the Gantt chart will be same, because the algorithm is same. So now we need to calculate the start time, we need to calculate the waiting time, we need to calculate the end time or the completion time, and then we need to calculate the turnaround time for each and every individual process. So having given this Gantt chart, which is as same as the previous slides, so I'll directly jump to the calculation portion. So the arrival time. So the arrival time for P1 is, so the arrival time for P1 is 0. So the start time, you all know, for P1 is 0. The start time for P1 is 0. The start time for P2 is 15. The start time for P3 is 23. The start time for P4 is 33. So how do we get this value start time? So start time of the process, the start time of successive process is the end time or the burst time or the completion time of previous process. So when what is the burst time of P1? So the burst time of P1 is 15. So only after 15 units P2 can start. So the start time of P2 is the burst time of P1, is the burst time of P1. Okay, so So one output will be the input to another. It's kind of like that. So start time of P1 is 0, and that's how we get the start time of P2 as 15. So the start time of P2 as 15 means the burst time of P1. So likewise, what is the start time of what is the start time of P3? The start time of P3 is the completion time of P2. So when P2 completed after 15 plus 8, that is 23. So that's how you get 23. Likewise, 33, we got it. Now let us calculate the waiting time. As I've already told you that waiting time can be calculated using the formula that start time minus arrival time. So 0 minus 0 is 0. 15 minus 1 is 14. 23 minus 2 is 21. 33 minus 3 is 30. So these are the waiting time for each and every individual process. So if you want to calculate the average waiting time, sum it up: 0 plus 14 plus 21 plus 30, which is equivalent to it is equals to 65 divided by 4, that is 16.25 units or milliseconds if milliseconds is the unit given in the question. Now let us try to calculate the completion time. So completion time or the end time means same. So we have used the abbreviation CT. CT stands for completion time. So completion time means when the process has completely executed the instruction and went out of the system. So P1 has completely executed the system at 15 units of time. So basically it's the burst time, right? So assuming that start time is arrival time is 0. So now what is the completion time for P2? P2 completion time is 15 plus 8, that is 23. So likewise you need to calculate the completion time. Now and the last column is the TAT. TAT stands for turnaround time. So how do you calculate the turnaround time? The turnaround time is calculated with the formula waiting time plus pause time. So 0 plus 15 is 15. Again, let us try to calculate the turnaround time for P2. So P2 burst time is 8. P2 burst time is 8, and the respect and corresponding waiting time is 14. So 8 plus 14 is 23. So that's how we 8 plus 14 is 23. So that's how we calculated turnaround time. Likewise, P3, the 10 is the burst time and waiting time is 21. So 10 plus 21 is 31. And likewise for P4, 3 plus 30, that is 33. So if you want to calculate the average turnaround time, sum it up, divide by number of process equals to whatever is the answer. So in this case, it is 25.5 units or milliseconds. Uh, so now in all these calculations, I have not considered the IO activity. If in the questions you are given at some IO activity for any process for any amount of time, you need to consider the same for calculations of waiting time, waiting average time, turnaround time, and average turnaround time. So now we will move on to the our implementation. So let us try to implement using the C programming language. So I'll quickly write down the program. So students, as you can see over here, I have declared two header file. I have created structure with some variable, p name for process name or ID, arrival time and burst time. Then declared an array of structure, temporary variables. These variables and this variable is different. One is local and one is global. Okay, so they will have different memory locations. These sections read the data from the user in the format of process ID, burst time, and arrival time. Then after that, I display the process. Now I have to further modify the code in such a way that I need to implement the FCFS. So for that, I need to have some additional variables like waiting time. So basically, I will only calculate the waiting time and average waiting time. Subsequently, you can do accordingly. So I'll add one more parameter, that is waiting time. So now we'll again quickly write down the code for the same. So we have added now two more variables, start time and waiting time, and added a function calculate wait. Basically, it calculates the waiting time and invoked at the end. So when the control of execution transfers from this or invokes this function call, the control will get transfer over here, wherein I have declared a statement that is the starting time of first process is the arrival time, and for the subsequent process, the start time for the subsequent process, the start time will be the burst time of previous process. So that's how I have calculated the start time of each and every process in the area of structure and stored accordingly. So now, for the first process, this is a start time. For the subsequent process, this is a start time. Now, next we have calculated waiting time for each and every process. So waiting time is calculated as arrival time minus start time. So that's how we calculate the waiting time. Likewise, you can calculate the turnaround time for each process, and I have calculated the average waiting time. So that's how the waiting time for each and every process is calculated. Now to calculate the average waiting time, we can have one more code, that is average waiting time. So you can have a float variable fl float avg underscore wt equals to 0. So average waiting time is calculated as, so I have calculated sum. I have declared the sum variable as 0.0 and add all the waiting time over here, and average waiting time is sum divided by number of process, which is equals to 4 in our case right now. And then you can display the message printf the average The average waiting time is percentage f, and the name of the variable is avg wait. So I'll show you the code. So just to summarize, these are the two header files. Structure I have declared, wherein for the first two row, for taking the input, I have taken it. For calculating the intermediate and the final results. Then after that, I've similarly in the main function, I've declared some temporary variables, and this section read the instruction from the user. This section read the instruction from the user, and after that, it also initializes the data into the variables. Then after that, uh, it displays for ensuring whether the data you have entered is as per the requirement or not. Then after that, you have invoked the function calculate function to calculate the average waiting time. So to calculate the average waiting time, you need to calculate the start time and waiting time of each and every process. So this section calculates the waiting time of each process and start time. So this section calculates the start time. This section calculates the waiting time of each process, and this section calculates the average waiting time. So if you want to display the same, the final result, whatever that you have, and that is average waiting time. So you can have one more this copy of the same statement over here, and simply add one more parameter, that is waiting time slash t wt. Okay, slash t wt, and one more. Yeah, you can have percentage t slash t percentage t and copy pi dot wt. Okay, so that's all you can how you can execute and learn on by own the remaining sections. So this is all from my end of for this topic. So if you have any questions, you kindly do post me or do inquire me right on it. Thank you very much.